Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries about one of the most mysterious features in the entire universe, the humongous structure that we sometimes refer to as the cosmic web. The largest known structure that contains a lot of other really huge structures inside of it, and that also serves as a kind of a foundation for a lot of galactic formation in the entire universe, but possibly serves a lot of other functions as well. And also a structure that does resemble a kind of a spider web, but a spider web that basically propagates through the entire universe and is more or less three-dimensional. And even though it was something theoretical at first and something that was only predicted, based on, for example, our understanding of how the universe evolved over the past 13.8 billion years, over time the scientists were able to actually find ways to even see it physically and to discover a lot of hints on what exactly it does to various galaxies and various galactic clusters. There are a few videos in the description below that talk a little bit more about some of the first discoveries, specifically visually confirming its existence, but also certain effects that cosmic web seems to have on various galactic structures and galaxies themselves. But I guess first, well, what exactly is this made out of? Well, the modern theories predict that this is probably mostly dark matter, but also a lot of other matter that because of the early expansion of the universe condensed into thicker structures, creating web-like strings. It also, for the most part, serves as a kind of a foundation for everything else around us. It also seems to guide matter, it seems to tell various particles where to go, and it, to some extent, serves as a kind of a tunnel for things to move across and for structures to follow. And in between the cosmic web, we have what's known as voids, or places of much lower density that very often contain almost nothing inside. A little bit of gas, but practically no galaxies. Here are just some of the better known voids very close to us. I think the most famous one must be the Buddha's void, even though the closest one is actually known as the local void. There's an older video on the channel that should be in the description that explores one of the loneliest galaxies in the universe. It's essentially located in the middle of the void. But as you can see from this three-dimensional map, these voids only exist because of the way that the cosmic web creates higher density filaments as the matter interacts and spreads across the universe. And in this sense, it also kind of acts like, I guess, a kind of a river. It tends to influence a lot of things inside those filaments, and even tends to orient galaxies in a certain way. Now this is still something that the scientists don't really understand very well, but it definitely has a lot of effect on a lot of galaxies and a lot of gas circulating those galaxies as well. For example, when it comes to our own galaxy, the Milky Way, one of the mysteries is why do certain satellite galaxies, and actually quite a lot of satellite galaxies, seem to orbit in a very similar fashion, in a very similar direction, and even in a relatively similar plane. This would not be possible if it wasn't for the cosmic web guiding all of them in a very certain way. And so it's kind of like as if all of these galaxies were flowing down the river all in the same direction, all at the same speed, which is kind of what happens here, but obviously on much larger scale. Anyway, a very fascinating structure, but a structure that up until relatively recently was always kind of theoretical and only based on various computer simulations like the one you see right here from the Illustris project. But the scientists always wanted to see it and wanted to investigate actual physical effects observable out there. The problem, of course, as I mentioned before, is that it's very difficult to observe the actual web. It's predominantly dark matter, and on the other hand, whatever is here does not produce a lot of light. And whatever light it does produce seems to be mostly in radio emissions, or basically radio light. But because a lot of galaxies are contained on the inside, normally the brighter light coming from the galaxies and galactic clusters completely outshines any light possibly coming from the web itself. And so even though we can see individual galaxies or galactic clusters, the web itself is very difficult to see. For example, here are some of the first official images from just a couple of years ago, which took quite a while to produce, and even here you can barely see anything. But the theory of the cosmic web always predicted another component that should be visible. Apart from the dark matter, which is invisible, and apart from some of the gas that should produce radio light, there should be quite a lot of magnetic fields present in the cosmic web as well, and specifically created by various energetic particles that interact with one another, producing various effects. And the thing is, magnetic fields tend to change the particles of light, creating what's known as polarization effect. And the polarization effect from the magnetic fields is extremely well understood in modern science, essentially when the light sort of shifts due to the electromagnetic interaction. For For example, this is one way we know that things like FRBs or fast radio bursts seem to come from extremely magnetic objects such as magnetars. The radio light coming from those objects is extremely polarized. And so as galactic filaments interact, and as they interact with other matter, they're going to be producing shock waves, which then create very powerful magnetic fields that should be visible with the radio telescope. And for the first time ever, that's exactly what the scientists have recently observed. They were able to observe definitive signs of polarized magnetic light produced by various shock waves located on the outskirts of galactic clusters, or basically exactly where we expect the cosmic web to be. But once again, getting all of this data and producing all of these images was not an easy task. It's still difficult to see this in the vicinity of various bright galaxies, because obviously galaxies have a lot of magnetic fields as well, and do produce their own polarized light that's generally brighter than everything else. And so to make this work, the scientists used a technique known as stacking. They averaged out many images that were way too faint to see individually, but overall this dramatically decreased the noise and enhanced the average signal that exposed the cosmic web. And that's because even in theory, this light is spread over a very large area, and so detecting it directly through one image is practically impossible. As a matter of fact, even the self-noise of a typical radio telescope is much louder than the light detected from just one of these images. But by stacking and averaging out images of approximately 600,000 pairs of galaxy clusters, they were able to combine this into the overall image you see right here. And this revealed that there's definitely something going on around the clusters, and the light coming from the outskirts of the galaxies or from the location of the cosmic web was about 6 times higher in polarization than the light from the galaxies themselves. Only 5% of galactic light was polarized, and about 30% of the light visible on the outskirts, which of course confirms that the cosmic web is definitely very magnetic, and does have a very certain direction of the magnetic flow, which probably causes all of the particles to follow, while also representing an important discovery of what we would call a cosmic magnetic field. A powerful magnetic field propagating through the entire universe, very likely following the cosmic web, and very likely influencing everything in the universe. How? Well, nobody knows. But remember, the gravity here also plays a big role, especially because there is a huge amount of dark matter on the inside. So this interaction could potentially one day explain a lot of inconsistency we've been detecting from, for example, the James Webb Space Telescope. How do certain galaxies form so quickly and become so massive so early on? A lot of previous cosmic simulations, such as the Illustris project, mostly rely on gravity to calculate what happens to galaxies early on. But the magnetic field here plays a huge role, and probably a much bigger role than these simulations show us. However, adding the magnetic component to these simulations have been extremely challenging, mostly because magnetic field is just very difficult to simulate. At the moment, no computer is powerful enough to produce simulations that combine both magnetic and gravity effects. But these new observations confirm that the magnetic field is just as important as gravity when it comes to the effects coming from the cosmic web itself. But obviously discovering some other intriguing facts. For example, discovering very clear rings of polarized light, usually surrounding cluster pairs, which means that the center of clusters is generally depolarized. And here the scientists believe it's really because of various collisions and a lot of activity, which creates very turbulent environments and prevents polarized light from forming. Whereas on the outskirts, where things are a little bit more quiet, and where the flow itself is very orderly and things seem to flow in one direction, the light on the edges of the cluster becomes much more polarized because of the magnetic fields very likely formed by various shock waves created on the outskirts, or essentially shock waves produced by various larger structures colliding or even the filaments interacting with one another. Although in reality, that's just a speculation. Nobody really knows where the actual magnetic fields come from when it comes to these very large structures. But these new observations and future observations, possibly using similar techniques, can hopefully one day help us answer all of these questions. For now though, it's a cool observation, another mystery to add to the list of mysteries of the universe, and another really cool image of the elusive cosmic web. But the scientists have made some really cool discoveries about the web in the last 2 or 3 years. Find those discoveries in the videos in the description. On that note, once something else is discovered, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.